This purple board shows an overview of the respiratory system. If we look again, this is similar to our half-head model that we saw in the previous video. So here we have again our nasal cavity, and it has within it the nasal sinuses. Those will act to warm and humidify the air, filter it, and trap pathogens as well as debris within the nose. Then we have our paranasal sinuses. So we have one in the frontal bone, we have one in the sphenoid bone, the maxillary, and the ethmoid, which are not being shown here. So those all also act to warm and humidify the air as well as lighten the skull. So if we look back behind our nasal cavity, we find our nasopharynx, which runs from the back of the nasal cavity down to the soft palate here. So from here to here is our nasopharynx. Now the only thing that will be passing through the nasopharynx will be air that's coming in through the nose. Now from the soft palate down to where we see the epiglottis at the level of about the hyoid bone here, that's what we call our oropharynx. So that's just behind the oral cavity there. Now in the oropharynx we do get a mixture of food and air. So that's why we have the structure called the epiglottis that's going to prevent any kind of food or fluid from entering the respiratory system. So from about the level of the hyoid bone where we see that epiglottis, that's where we begin our Laryngopharynx. And here is the Laryngopharynx, which will ultimately give rise to the esophagus. So food stuff will travel through there. And then we have our larynx, which will give rise to our trachea. Here, so we can see the trachea here, and then we have our lungs here. Remember, the right lung will have 3 lobes, and the left will have 2 because the heart leans towards the left lung. Also, something that we can see here is the parietal layers and the visceral layers of the serous membranes surrounding the lungs. So remember, we had those pleural membranes surrounding the lungs that will secrete serous fluid. The parietal will be fused closest to the body cavity, and the visceral will be fused on the lung itself. Okay, so here we can see the parietal layer fused to the cavity, and here we can see the visceral layer fused to the lung itself. Now in between here, we have our pleural cavity, and that's where we have that serous membrane. Serous fluid. So if we look over here, we can see here's our larynx. This is our thyroid cartilage of the larynx. The larynx sits just beneath the hyoid bone, which is seen here. And then the larynx will give rise to the trachea. The trachea has little cartilage rings made up of hyaline cartilage, and they will travel all the way down the main bronchi. So the trachea bifurcates into the right and the left bronchi. These are called primary bronchi. They are the first divisions from the trachea. Then we have secondary bronchi. So those are these ones here. And you'll notice that they go along with the number of lobes that are found in each lung. So the secondary bronchi here, we have 1, 2, 3 for the right lung. They're also termed lobar bronchi. And then over here you can see we have 2 secondary lobar bronchi for the left lung. Then the lobar bronchi will further divide into what are called segmental or tertiary bronchi. So throughout all these bronchi, primary, secondary, and tertiary, we see these cartilaginous rings, and we will also find pseudostratified columnar ciliated epithelium. As we move down the respiratory tree, from our bronchi, we will go into our bronchioles, where we start to see a change into simple cuboidal epithelium. Then the terminal bronchioles will give rise to our respiratory bronchioles. So here, this is representing our respiratory zone. All the other structures, so from the trachea, the primary through tertiary bronchi, and down to the terminal bronchioles, are all considered the conducting zone of your respiratory system. And that just means that it's simply carrying the air in and out. Whereas the respiratory zone, that's where we will be getting gas exchange. So here we can see we have respiratory bronchioles, and those are going to give rise into outpocketings called alveoli. Now in the alveoli, we transition from that simple cuboidal epithelium to a simple squamous epithelium. And this just allows for more easy diffusion of these gases between the capillary beds and our alveoli. As we can see here, we have a blue blood vessel, which will be representing our pulmonary artery, because that's the one that's bringing that deoxygenated blood to the lungs to pick it up. And then here in red, we're seeing our pulmonary veins that will take that oxygenated blood back to the left atrium of our heart.